So last time we talked about composite functions, f of g, g of f. You're taking one function, plugging it into another. Today we're going to talk about the domains of those, and so we're going to talk about domain restrictions. So there's two main domain restrictions. You cannot divide by zero, so no zero denominator. You're not allowed to divide by zero. That's the big one. And I call these ones the troublemakers. So you cannot have a zero in the denominator. So for example, give me like some little numbers, like single digit numbers. We have 3 over x minus 4. What would make that denominator 0? Who is our troublemaker? 4. How would we leave out 4? Like, how would you write this domain? Negative infinity to 4, and then 4 to infinity. So you're saying you want everything to the left of 4, everything to the right of 4, but not 4. When you set up a problem like this, because we're going to get to this later in the lesson, you use a not equal to. We're saying we don't want 4. Everybody except 4 is invited to the domain party. So it's like the parking sign, like the no parking sign, the line through. So that's one main restriction. The other one is you cannot have a negative, no negative, under an even root. Now, most of the time you see square roots. In fact, I don't think I put anything other than square roots on here. But for the sake of being thorough, you can't have a negative under a 4th root or a 6th root or an 8th root or any of those as well. If it's an even root, you can't have a negative under there. So again, let me just make up an example. So say you had something like square root of x minus 2. I always think of it from a graphing perspective. That gives you a visual. Most of us are like very visual learners. If you can see a picture, that helps a lot. Do you remember transformations? It was unit 1. I know that was back in September. What direction did this move? And be careful, it's gone backwards. Went right 2. If you move this right 2, it's going to look something like this. That's the visual. Remember how the square root is that like half parabola on its side? It can't be a whole parabola because it would fail a vertical line test, but like that half parabola. Think about what it would look like. You can always just draw it. It takes 2 seconds. What is that domain? You sweep left to right. It would be starting where? 2 to infinity. Bracket or parenthesis on the 2? Why bracket? That's correct. Yep, it's a closed circle. There's like actually a point there. So bracket on the 2. When you set up problems like this, you will use a greater than or equal to. You want everything above that number. So this one is like we're just kicking out one number. This is saying we want everything bigger than a certain number. You can't have a negative under there, so we want everything that's above that. So everything positive. Now the combined functions, do you remember when we just added the 2 functions together or subtracted them or multiplied or divided them? Do you remember that? Okay. For those, you're just going to combine the 2 domains. Basically, you just take them both into consideration. So you just combine them. And we're only going to do actually adding for these ones. We're just going to add them together. So we're going to find f plus g. You're just going to add the 2 functions together. And then we're going to find the or actually, I guess it doesn't even say to add them together. Just find the domain of adding them together. We don't even need to find that. Just what's the domain? So let's do the domains of them separately first. What would this graph look like since there's a squared in it? Visually, what would it look like? There's a squared. A parabola. What's the domain? Good job. What's the domain for any parabola? All reals. It's everything. A parabola is everything. It's going to go left and right forever. They don't have any issues. It's all good. This one is really similar to the example I just made up over here. What direction did this one shift? Right 5. So it's going to be starting at 5 and go like this. So the domain would be bracket 5 to infinity. So your final answer to the whole thing, we want to combine those together. Well, this one doesn't have any problems. So the answer would just be whatever this restriction is. Does that make sense? Like if this one didn't have any problems, it's just whatever that one is. Like that's your answer. If you combine those together, It's just gonna be this one. Now, if they both have a restriction, you have to do them both. And I'll do an example like that. So look at this one. This is one with a troublemaker. Who's your troublemaker? 9. You want everybody except 9. Kick out 9. 9 is causing problems. And then this one, if you were to graph that, what would it look like? It's y equals mx plus b, if you want to think of it that way. Yeah, linear. It's a line, right? What's the domain for a line? All reals, everything. So if this one's everything, that's all good. So if you combine them together, your answer would just be this. It's like whatever the most restricted one is, basically. But you're just combining them together. Now we're going to do ones where they both have a restriction, okay? And it's not any harder. You just do both things at the same time. Who's our troublemaker for this guy? Like what number gets left out? Leave out -2. -2 is causing problems. Kick him out. And then what direction did this one move? Moved left 5. So it'll be bracket and then what? If it went left. Good. -5 to infinity. So they both have a restriction. You need to do both at the same time. We want to be bracket -5 to infinity, but also boot out -2. Are you following me there? Yeah. Right. So it's going to look like this. Bracket -5, bless you. And then you want to skip over -2 on your way to infinity. So you're doing both of those things together. You're just basically mushing them together. You're doing both of them. You're combining it. Doesn't seem like anyone's panicking. Did that sit well? All right, let's try another one of those then. What's your domain for this one? Yeah, we want to leave out 6, right? So -infinity to 6, union 6 to infinity. And then how about the other one? Yeah, -1, because it went left 1, and then onwards. Or that was a horrible infinity. So whenever you combine them, you want to do both of those things at the same time. So you want to be -1 to infinity, but also kick out 6. So it will look like that. So you want everything from -1 to 6 and 6 to infinity. Are we good on that? Yeah. Okay. So that's just if you're adding them together. You're just combining them. It's F plus G. Now we're going to do the composite ones. These are a little bit tougher. So I was rethinking how I was going to go through this. I'm going to kind of skip this explanation for right now. I want us to go through and just do the domains of all the regular functions. Then we'll do a break and then we'll come back and I'll show you how to put them together. Also, I have it set up so that I left all these lines to write on. I find this goes better if you separate your paper. Do you see how like that's problem 5 and then this is going to be problem 6? Like if you just draw a line through so you don't get them mixed up with each other, just found that like goes better. So let's do the domains of these individually. What does this one look like? Parabola, U shape. So what's the domain? All reals, everything. Life is good. What's this one look like? A line. What's the domain of a line? All reals. Life is good. And then we're going to find the composites. This is review of what we did last class. For F, do you remember telephone game? F of G. G is getting plugged into F. So I'm going to take this whole thing, plug it in over here. And I left a little space so that you can work this out. It's going to be 3. And then you would have instead, you remember you took out a word and replaced it with a new word? Remember those? You're going to take out X, replace it with X minus 5. So you would have X minus 5 squared. That means you should write X minus 5 twice. Squared means write it twice. And then at the end, what do we still have? plus 4. Good. So we're going to multiply all that together. It's tedious, but it's not hard. You just can't be a giver-upper, okay? The 3 is going to hang out, put a parenthesis. First, outside, inside, last. X times x. X squared. Minus 5x minus 5x would be minus 10x. Good. Negative 5 times negative 5 is 25. Good. Thank you for not going to sleep. I know it's not like super interesting. I will try to be as entertaining as possible. I can't change that this is the material. Last steps, I'm going to write it on like the answer line. Distribute the 3. That'll give you 3x squared minus what? Be 30x. 3 times 5, 75, but then plus 4 more, so 79. Now, usually when you do these, one way is like kind of tedious, and then the other way isn't so bad. Which function gets plugged into which for this one? Good, perfect. F gets plugged into G. This entire thing gets plugged in over here. So it's actually just going to be all of that minus 5. So I wrote out the middle step, but if you could even do that in your head, I'm fine with that. That'll be 3x squared minus 1. That's sort of review of what we did last time. I'm going to go through and do that for each problem, and then like we'll come back and I'll teach you how to do these because that's the harder part. But let's do that because that's review for each of these. All right, so go down to number 6. This is a parabola. What's our domain? All reals. Are you getting that that's a really common answer? Like that shows up a lot. Like if you get that for a lot of answers, you're doing fine. How about this one? Now that's not going to be all reals. Good. Bracket -4 to infinity. It went left 4. And then we're going to find the composites. For this one, G gets plugged into F. If it helps you to draw the little arrow, then do that. I just always draw that little like rainbow arrow. This entire thing is going to get plugged in over here. So I'm going to take out X, replace it with all of that. Now remember we had this conversation. Does that cancel or hands off? It does because it's the whole thing. So you can cancel the square root and the squared and it'll just be X plus 4. All right, for this one, F gets plugged into G. This X squared is going to get plugged in over here. So I'm going to take out X and replace it with X squared. Why does that one not cancel? Like you cannot do anything to that. Only the X is squared. It's not the whole thing. Okay, again, I'm gonna leave these. I want to go through and do this for each problem, and then we'll do a break, and then I'll come back and teach you how to do that. Do the review part first. And again, I'm leaving lines for everything. So if you want to separate these problems from each other, like so you don't get them mixed up, if you want to draw lines across, I've just found that helps people. There's only 3 questions on this page. I just wrote lines for you to put everything on. All right, and we'll kind of pick up the pace with this a little bit. What is our domain for this one? Bracket 9 to infinity, moved right 9. And then this one, all reals. When there's a squared, it's a parabola, it's going to be all reals. Right here, G gets plugged into F. You're going to take this X squared, plug it in over here. So it'll be square root X squared minus 9. Hands off. Only the X is squared, not the whole thing. You can't reduce anything if it's only part of it. So just do nothing. Isn't that great? No work. We love no work, right? Right here, you're going to plug F into G. This whole thing gets plugged in over here. Now, that would look like this. So what is going to happen there? Those are going to cancel. You'll just have X minus 9. Number 8, domain. Who's your troublemaker here? Who do we have to kick out? 0. Kick out 0. And then what about this guy? Everything, right? What would this look like if you graphed it? A line. Bless you. A line is going to be everything. So here, G gets plugged into F. This X plus 3 is going to get put in for X. We're going to replace X with X plus 3. That would look like this. There's nothing you can do to that, which is great. Bless you. We love no work. And for this one, F gets plugged into G. This 1 over X gets plugged in over here. So that'll be 1 over X and then a plus 3, which also you cannot do anything to. There's a lot of these where you just write the answer. Like we're not really doing anything. Domain for this one. What direction did it shift? Went right, so it'll be bracket 1 to infinity. And then that's a parabola because of the squared. So everything. So here, G gets plugged into F. This 1/4 X squared is going to get plugged into here. You're going to take out X, replace it with all of this. So square root of all of that stuff minus 1. Only the X is being squared, so you can't cancel anything, not the whole thing. For this one, F gets plugged into G. So this is getting plugged in for X over here. That's going to be a different story. It's the entire square root that's getting squared. So you can cancel those. You'll have 1/4 times X minus 1. And then what's the last step that you would have to do with that? Distribute. So it'll be 1/4 X minus 1/4. All right, it seems like we're kind of chit-chatting, so I'm gonna go over these. All right, what did you put for 10 for this first one? Bless you. What did you leave out? Bless you. -3 is your troublemaker. Good. And then an absolute value, that's a V shape. That's going to go left and right forever. So just like a parabola, that'll be everything. All right, F of G. G gets plugged into F. This whole thing gets plugged in for X over here. I'm going to remove X, replace it with all of that. So it'll be 1 over all of this plus 3. Do not combine those. That's the most commonly missed thing on the test, and I kind of don't get it because these bars are here as a reminder. Don't put them together. Just do nothing, okay? All right, here F gets plugged into G. This entire fraction is going to get plugged in over here. We're going to take out X and replace it with all of that. So you're going to have this gigantic absolute value with all this stuff inside of it, and you're going to do nothing to it. No work. We love no work. Leave it alone. Did that go okay? Okay. What are we leaving out for this one? Who's the troublemaker? 7. Kick out 7. He's a problem. And then absolute value is everything. Right here, G gets plugged into F. This absolute value gets plugged in right over here. So 1 over all of that minus 7. What do? Nothing. Okay? F gets plugged into G. This fraction is going to get plugged in over here. So same thing. You're going to rewrite that plus 4 and then just walk away. All right, now here's one where they both have a restriction. What direction did this graph shift? Left 2. So it'll be bracket and then what? -2. Good. To infinity. And then this one, we're going to leave out 6. 6 is a troublemaker. Kick him out. Right here, G gets plugged into F. So this entire fraction is going to get plugged in over there. And then you're not going to do anything to it. Just this whole thing gets plugged in for X right there. I kind of love those. Like, you're not doing anything. Do you know what I'm saying? Like, It's almost no math. It's really just direction following. All right, and then this one, f gets plugged into g. This entire square root gets plugged in over here. So 1 over square root of x plus 2 minus 6. Do nothing. Did that go okay? We're all right there? Okay, so that is stuff that we've learned before, how to do a domain and how to do f of g. This is the new thing I'm going to teach you, which is how to do the domain of the composite function. Pep talk. This is actually a little bit of a more difficult topic, okay? People do struggle with this a little bit more, but I believe in you. But what I want you to remember is this is a very, very small portion of what we're doing. Look through the notes that we just did. Do you see how much we already filled in? Yeah. So like what I'm about to show you is a more difficult thing to do, but it's a very small part of what we're doing. Does this like, I just want to bring down the anxiety, okay? So yeah, it's a little tougher, but it's not like the biggest thing that we're doing. So I'm going to start with a visual to show you. We're going to draw a circle. Here's where all of the x's live. And we're going to draw a circle. If we put all of those x's into function g, then what we get back is g of x. Did you ever have a teacher teach a function to you as a function machine? Some middle school teachers do that, like where you plug something in, or like what I always bring up is the Sneetches, but see, that's kind of like outdated. Did anyone ever watch the Sneetches when they were little and they go into like the star on machine and they get a star and they come out? Some of you are nodding. If you've never watched the Sneetches, go watch it. It's a great cartoon. But anyway, you put in x to function g, you get back g of x. All right, it's like the telephone game. It gave you an input, you changed it, you got something else. This is the domain of g, and this is the range of g. Domain range. So it's what we plugged in and then what we get back out. Domain of g, range of g. So with a composite function, you take this new output and you plug it into function f. So you're passing it along to another function, like the telephone game. Each of you represented a function. And what do you get back out at the end? Good, f of g of x. You drew your circles kind of tiny. That's okay though. So this would be the domain of f, and this would be the range of f. So here's where this gets a little complicated. You have to make these two things make friends. The range for g has to comply with the domain of f, and that's where it gets a little tough. Okay, but this is your visual so you can like see what's actually happening. So here are your steps. To find the domain of f of g, step one, there's gonna be 2 steps here. Step one, if the inside function, and I call them outside and inside, don't get hung up on f and g, because if we rearrange it, then it's gonna be opposite, okay? If the inside function has a restriction, and what I mean by restriction, I mean it's not everything. Like there's some kind of rule. If the inside function has a restriction, keep it, period. You're just gonna keep that. If the inside function has some kind of restriction, you're stuck with it. Good so far? All right, check the inside one. If it has a rule, keep it. All right, and then the second thing is the inside function must comply with the domain of the outside function. And that's where you kind of have to set up a problem to work out. That's getting these two things to agree, okay? So your inside function has to comply. Do you guys know what the word comply means? Like if you're in compliance, you're like following the rules, right? The inside function must comply with the domain of the outside function. We're going to go through this slowly and carefully because this is the tougher part. But again, remember, it's a small part of what we're doing, so don't get like too upset, right? So we're looking at number 5. For f of g, which one is the inside function, f or g? G is inside. A lot of this is just going to be me pointing to stuff. You're going to have to like keep your eyes open and watch. Does g have a restriction? No. No rules. Anything goes. Great. So rule number one, we're all good. Outside function is f. Does f have a restriction? No. Great. So it's everything. I made the first one everything. And it's going to be the same for g of f. If both of these are good to go, they don't have any rules, then this domain is also going to be like, does that make sense? Like if neither of the functions had anything wrong, then when you put them together, like you're still not going to have any rules. Okay. So let's look at 6. F of g, which one's inside? G. Does g have a restriction? Look, we wrote it right here. Yes. You are stuck with it. You're stuck with it. Does the outside function, does f have a restriction? No. Great. That means this is just your answer. You will just copy it over. If the inside function has a restriction, you are stuck with it. Now, when we do this one, now which one is the inside function? F. Does f have a restriction? No. Great. Does the outside function have a restriction? Yes. Okay, this is where it gets complicated. Hey, f of x, listen up. You better follow this rule or no dessert. Do you get what I'm saying? It's like, hey, f of x, you better comply with you better stay bigger than -4 f of x, or else take away that cell phone. Okay. So you're going to take f of x, this x squared, we're going to set up a problem. You're going to take f of x and say, hey, you need to stay bigger than -4. That's the rule. Hey, f of x, you better stay bigger than -4. And then you kind of see where that takes you. It's kind of like, hey, where are we going to end up? If you square a number, it is always going to be what? Positive. So if it's positive, it would be bigger than -4. So we ended up with a statement that's always true. That's always true. It's kind of like when your parents are like, hey, I thought I told you to do your homework. And you're like, geez, I already did. I did it already. Like you're already in compliance. Do you see what I'm saying? Okay. So this will be everything. I can't during class time, honey. I can't during class time. I'm teaching class. You'll have to come back during flex. I wrote you flex pass. Come back during flex, okay? All right, number 7. Which one is the inside function? G. Look at G. Does G have a restriction? No. Great. F is outside. Does F have a restriction? Yes. Hey, G of X, you better stay bigger than 9 or else. Do you get what I'm saying? Like, hey, G of X, you better comply with this rule. So you're going to take G of X, this X squared, and you're going to say, hey, you better stay bigger than 9. And then you see where that leads you. The one we just did, it was always true. So we were good. It was like it was already following the rule. It was already in compliance. So we were all good. Now, this one's going to be a little bit different. What would you do to get rid of the squared? You would square root, but when you square root 9, it's not just 3. It's also -3. You get the plus and -3. So we end up with here, x is bigger than 3. And then when you do the -3, what do you have to do with the symbol? When you deal with a negative in there, you're going to have to flip it the other way. And so when you go to write your answer, I think of this visually because I think visually it helps a lot. And also these graphs are kind of cute. You want everything bigger than 3. So here's what it'll look like. Here's 3. You want everything going that way from 3, bigger than 3, and then smaller than -3. That's what this graph looks like. I always say it looks like little alien antenna. That's what the graph looks like. Isn't that cute? Cute little graph. I like it. Anyway, that's what those ones look like. So how would you write that answer? Well, if that's what it looks like, sweep left to right, it'll be -infinity to what? -3 with a bracket. Good. That's like this little antenna. Union, and then where do we pick up on the other side? 3 with a bracket. Good. To infinity. They look like this. They're cute. Little ant antenna. I like those ones. All right. Which one's the inside function? F. Does F have a restriction? What does that mean? Keep it. Keep it. If the inside function has a restriction, keep it. Does the outside function have a restriction? No. Great. That means this is just your answer. You don't have to set up a problem because the outside function didn't have any rules. They were like, hey, anything goes. Let's try it again. Focus. Because they're like very, very tired today. Should have brought espresso shots for everybody or something. Which one's the inside function? G. Does G have a restriction? Great. Does F have a restriction? Hey, G of X, you better not equal 0. I better not hear that you were hanging out with 0 or else. Do you get what I'm saying? So you're going to take G of X, this X plus 3, and say, hey, you better not equal 0. I better not hear that you're hanging out with 0 or else taking your car away. And then you see where that takes you. What would you do to solve that? Yeah, you'd subtract over the 3. X is not allowed to be -3. Now, with this one, could you have looked at this and said, hey, it's not going to be -3? So you can actually do it that way too, but -3 is your troublemaker. Correct, because you're trying to leave it out. Yes, parentheses because you're trying to exclude it. So look at this one. F is the inside function. Does F have a restriction? What does that mean? Keep it. Does G have a restriction? No. So this is just your answer. And again, you could kind of just look at this and go, oh, X can't be 0. Like you can kind of just look at that as well. It sort of works out that way. You're going to be okay. You got to do a bunch of these to get the hang of it. But we're not doing a whole lot of like work. There's not like a whole lot of writing with this. All right, which one's inside? G. Does G have a restriction? Fantastic. Does F have a restriction? Hey, G of X, you better what? What's the rule? Not be, you better stay bigger than 1 G of X or else. So you're going to take this G of X, this 1/4 X squared, and say, hey, you better stay bigger than 1 or else. And then you try to solve that. What would you do to cancel out a 1/4? Multiply by 4. And now that's really similar to the number 7 that we did. You would square root and you would get 2 and -2. It's going to look like these little antennae. If you want to draw it, you can do that. I like to draw it because first of all, they're cute graphs and also the visual helps. So something like this. That's what it's going to look like. So how do we write that answer? -infinity to -2 with a bracket, union 2 to infinity. You want to write that down for me, Grace? You got that? All right, cool. Which one's the inside function here? F. Does F have a restriction? What does that mean? Keep it. Does G have a restriction? No. So this is just your answer. One to infinity. Next time.
Wait, actually?
Yeah.
Oh.
Which one is the inside function? G. Does G have a restriction? No. Great. Does F have a restriction? Hey, G of X, you better not what? You better not be hanging out with -3. If I find out you're hanging out with -3, we're going to have some problems. Okay? So you're going to take G of X, that's your absolute value, X plus 2, and say, hey, you are not allowed to be -3. Well, wait, hold on. We're going to see where that takes us. If you absolute value something, it is always positive. So this is already true. If this is always positive, it's never going to be -3. And again, that's like when your parents come over to you and they're like, I thought I told you to do your homework. And you're like, geez, I already did. Leave me alone. It's like it's already following the rules. So what's your answer? Yeah, everything. It's like, geez, get off my back. I already did it. Come on. I try to make it funny so you'll remember it. Also, that's like what we're doing. All right, which one's the inside function here? F. Does F have a restriction? What does that mean? Keep it. Does G have a restriction? Great, that's just your answer. Do you feel how after we do a ton of them, that's when you start to like get it? You have to do a bunch of, it's like a drill and practice thing. You're gonna be just fine. Which one is inside? G. Does G have any problems? No. Great. Does F have any problems? Hey, G of X, you better not what? You better not be hanging out with 7 or else. So we're going to take this G of X, this absolute value of X plus 4 and say, hey, you better not equal 7 or else. If I find out you equal 7, many problems. Now that one we're going to actually be able to work out. Let's see who remembers this. When I used to teach algebra 2, I would just run back and forth across the room. An absolute value does turn everything positive, but because that's it, no, take 2 words. The reason it turns everything positive is because it's a distance from 0. What do we want to be? 7 units away from 0. How can I be 7 units away from 0? I can either go to 7 or I can go to -7. Do you remember in algebra 2 splitting these apart? You have the positive one and the negative one. I think it's like one of the first things you do, like unit 2 or 3 in the beginning of the year. So you're going to have X plus 4 can't be 7. X plus 4 can't be -7, and you're going to get 2 troublemakers. You're going to get 2 values that you're not allowed.
Wait, so do you drop that?
Correct. That when you split it, you drop the absolute value bars. Because that's like the definition of what an absolute value is your distance from 0. So X cannot be what for this one? You would subtract the 4, so 3. -11. You would subtract 4. Yeah, it's a 4, not a 3. Oh, that 3 right there. No. Now, which one do you have to skip over first? There's going to be like a bunch of unions in this thing. Good. It has to go smallest to biggest. So skip over -11 and then skip over 3. I wrote too big. I'm sorry. Which is the inside function here? F. Does F have a restriction? Yes. What does that mean? Keep it. Does G have a restriction? No. So that's your answer. Yeah, G was like, I'm good. I don't have any problems. Anything goes. No rules. All right. Now this one, do you see how they both have a restriction? Okay. We're not going to do this one. That actually ends up being a very, very complicated thing. We're going to just do this one. Okay. I would never ask you something like this one comes out to be on a test or anything. So we're just going to let that go. Which one is the inside function? F. Does F have a restriction? What does that mean? Keep it. Keep it. Okay. Does G have a restriction? So there's 2 things going on here. Hey, F of X, you better not equal 6 or else. So we're going to take this F of X, the whole function, and say, hey, you better not equal 6. You better not equal 6 or else. And then you would start to solve that. What would you do to get rid of a square root? Square. X plus 2 cannot be 36. You like did the whole thing in your head. So X can't be 34. 34 is a troublemaker. But remember, we had to keep this restriction. Do you remember F was the inside one? We have to keep this. So you want to do -2 to infinity, but also leave out 34. So it's gonna look like this. Then 34 to infinity. Oops, I'm sorry. I can't talk and write at the same time. We have 25 minutes. Or here, let me pause this, halt this recording.